Okay, Assalamu alaikum. Good morning. Now you can see the screen. I have prepared some revision questions for you. I will send you the recording, okay? So don't worry about the record. Don't worry. Okay. So here in this diagram, can you see the diagram? Remember we learned about LAN and WAN, okay? And we learned about some network devices. Give me an example of network device. Switch, router is a network device. So if I ask you here, in this circuit, or in this diagram, the first part, how many network devices do we have here in this circuit? How many network devices? Four. What are they? Yes. Two switches, two routers. Very good. What about in this diagram here? Let me increase the size. Here we have two routers, two switches. Okay. These are in the first diagram. This is one router. This is router 2. This is switch. This is switch 2. Okay, and we have written for you the type of the switch and the type of the router. This is a router 1841. Okay. What is this number meaning, dash 24? Dash 24 means what? Yeah, the number of ports in the switch. How many ports are there? Okay. And this is the PC. 10.0.0.2 is actually the IP address of the PC given for you. So here, okay. How many LANs we have here in this diagram? LAN. We have here. Here we have one LAN. This is one LAN. And this is another LAN. Okay. And this is the WAN link between the router 1 and router 2. This you need to go maybe through the telecom company. But here we have one LAN. Okay, because each at the port of this router we have one LAN. The LAN inside the LAN we have a switch. Okay. And here inside this LAN we have one switch and two computers. The routers are connecting between these two networks. So what is a function of a router? A router connects different LANs, okay, as we mentioned before. Which device is active inside the LAN? The switch works inside the LAN. Very good. We have another example here. How many LANs we have here? 2. Very good. We have one part here. 1, 2. Okay. How many routers? 1. So this is the symbol for router. This is a switch. This is a switch. I have a question for you. In this example here, how many broadcast domains do we have? Remember we said that the router will prevent the broadcast. So here, each port of the router, each LAN on the side of the router is a broadcast. So here we have 2 broadcast domains, 2 broadcast. Any broadcast here will go only to all the computers in LAN 1. If I have a broadcast in LAN 2, it will go to all the computers in LAN 2. But it will not cross the router. So here I have 2 broadcasts domains. Okay? Understood? We have another example here. Let me quantify it. Who can tell us how many, take your time, how many broadcast domains do we have here? Take your time, take your time, take your time. 4, very good. 4, you said 4? Well, yeah, 4. You want to explain? 4, it is 4. Good. Why? Because this is also a broadcast domain. That's why I told you take your time. It's a bit tricky. So we have 1, 2, 3. What about this? It's a broadcast domain. So we have 4. Because it is connected to one side of the router only. Okay? So it's a broadcast. So if someone here make a broadcast, it will arrive to here. Okay? We have something also called collision domain. Okay? Here we have the red ones are collision domains. So how many collision domain do we have? Yes, 8. You can count here. The red colors are collision. Red color is for collision domain or for collision. Here we could have a collision. Okay. Any questions about this? Which part, the switch uses which address, IP address or hardware address or MAC address? The switch depends on the MAC address. The switch depends on the MAC address, yes. Another question for you, or I want to talk about, is how many bits do we have in the IP address? 32 bits. The IP address is divided into 4 octets. Each octet is 8 bits. So the total number of bits is 32. Yeah, 8 times 4, 32 bits. That's the IP address version 4. Okay. MAC address, how many bits in the MAC address is? So IP version, it's 32. MAC address, we have 48 bits. 48 bits. In IP version 6, which is the latest version of IP, it is double it, 128. 128 bits. 128 bits. That's why with IP version 6, now you can have IP address for everything. Okay. Which OSI, now let's talk about the OSI layers. We said how many layers in the OSI model? 7 layers. Which layer encapsulates the source and destination IP address around the data, or deals with the IP address, or process the IP address? Network. 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 Network layer. Now we need to talk about what we call the PDU inside each layer. So in the application layer, what is the PDU called? Data. What about inside the transport layer? Segment. Very good. In the transport layer, it is segment. In the network layer, packet. In the what's the layer next? Layer number 2. That's starting with letter D. Data link layer. What's the name of the PDU there? Frame. And then in the physical layer, it is electronic signals or bits. Okay. Each of these here in the layer, in the transport layer, it will add to the PDU. Okay. So when the data is traveling, each time in each layer, it gets some addresses or some information. Frame only adds header and trailer to the data. Adds header and trailer. Okay. By the way, frame will have what? The MAC address of source and destination. And the destination. Frame, yeah. Sorry? Header and trailer, yeah. Frame. Okay. So let me take this information there because we have the answers here. So this is the information that we have just discussed here. Okay. Any questions about this? Okay. How many layers in the TCP/IP model according to the slides? Look at your slides, please. What are they? What are they? Application, transport, internet, and network access. So it's 4 layers. Some books say 5, but we will go with our textbook. It is 4 layers. Okay. Let me upload also the file. One more, more information, also important information is, we call the medium or the medium between the sender and the receiver transmission medium. As you look here in the diagram, this is my transmission medium. This could be a cable or maybe wireless, correct? What are the type of cables? We can have maybe copper, fiber optic, okay? So all communication methods have three elements in common: source, destination, and transmission medium. You need to know the rules or protocol that there should be a protocol to govern or organize this networking or communication. Okay. Now, these are some important characteristics of a protocol: the format, the message size, the timing, the encoding. What is encoding? Messages sent across the network are first converted into bits, okay? By the sending host. Each bit is encoded into a pattern, maybe of sound, or maybe light wave if you are using fiber optic, according to your medium, okay? Or maybe electrical impulses. The destination will receive the signal and decode it so that it is back to the original format. Then we have the encapsulation and the message patterns. We have two important communication standards, which are ISO and TCP/IP model. ISO have 7 layers, TCP/IP has 4 layers. These are the layers of the OSI: application, presentation, session, transport, network, data link, physical. This is layer number 1 here, and then it goes up to layer number 7. Okay, the first 3 layers are called upper layers. The down 4 layers are called lower layers. Okay. We already talked about data. In the upper layer, it is called data. Then it is segment. You see, header is added in the segment. In the packet, header is added. In the frame, we have trailer and header. Then it is converted into bits. Okay. These are some sample applications layer protocols, such as for SMTP. We have post office protocol for email. We have also internet message access protocol, IMAP. We have the hypertext HTTP for browsing the internet requests. We have the FTP for file transfer. Okay. Here we have one note: application does not reside on the application layer of the OSI model. In reality, they sit above the OSI model. Yes, that's understood. Now here are the different, what is done in each layer you need to know. Application layer, a presentation layer, we have formatting, compression, encryption. In session layer, it will create and maintain dialogue. Okay, remember this, dialogues between source and destination applications, and handles the exchange of information. Then the transport layer, it's responsible for the delivery of a message from a process to another. What is a process? A process is an application or message program running on a host. Each process is given a port number so that they are identified by port number. There are two main types of transport protocols. We have TCP and we have UDP. Okay. This is the TCP. The TCP format is longer. It is heavier. That's why TCP is slower, little bit than UDP. But TCP is reliable and it's connection oriented. UDP is fast, but it is not reliable and it is connectionless. Yani like what you use in YouTube. YouTube, when you are watching, it's not guaranteed, right? Sometimes frames are lost, dropped, but not like when you read email from someone. When you read email, do you find some words inside the message deleted? Okay. This is the process to process delivery. So email is delivered to the destination. For the network layer, it is responsible for the delivery of individual packets from the source host to the destination. It relies on the logical addressing or the IP address. This is how it looks like, the format of the packet. We have destination IP address, source IP address, and some other fields. Routing, as you can see here, we have a client, we have a server. When the data is traveling from the client to the server, it is going through these routers. So the router, when receives the packet, it will check the source IP and the destination IP. Then it will forward it accordingly. Okay. So it will manage the traffic according to the IP address. Any questions? IP address is 32 bits. Each bit is either 0 or 1. A byte is 8 bits. Okay, a byte is 8 bits. Octet is 8 bits also. Okay, this is an example of a IP address 172.16.30.56. You see how 16 is represented 0 from right to left, 0, 0, 0, 0, 1. Because if I 1, 2, 4, 8, 16, the values of the one according to its position. Okay, which one of these is invalid? Why is this one invalid? Because each octet should not be more than 255. So this one is invalid, correct? This one is invalid. This one is valid. So if you see something above 255, then it is invalid address. Okay? So this is the part 1 of the revision. Let us have a short break.